Okay, so now we're ready for 6C, the laws or properties of logarithms. Now, if you want to kind of see how these work, what I recommend, if you want to pause the video, get your calculator out, and figure out, do this little activity. Find the log of 2 and make sure you end the parenthesis plus the log of 3. Find this value. Then what's the log of 6? These two go together, these two go together, these two go together. So if you want to have like a demonstration, this kind of shows you nicely that this works. But I'm going to keep moving. So the log properties go straight back to exponential properties. Let's think back. If we've got bases that are the same and we are multiplying bases, you keep the base the same. What do you do with the exponents? Add. So just like exponential properties, log properties share the same qualities. If you are adding the log, you multiply the bases. Let's think about the division rule. X to the 5th divided by x squared. When you divide bases that are the same, subtract the exponents. So with logs, when you're subtracting logs, you divide the bases. The last one, think power to a power. X to the 3rd to the 5th. Power to a power, you multiply. So if a base inside a log has an exponent, that exponent can be put in front of the log. I usually go backwards from this. This m can either be in the front of the log, take m times log b, or it can be b to the m power. So power to a power, we multiply. When multiplying, we can also put it back to being a power. Now, one of the things we're going to have to do a little bit more this next year is start introducing proofs and talk about what proofs are. Now, don't be scared. Don't think of the 2-column proofs you had in geometry and stuff like that. You're starting with this log base a of mn. We're going to show that these equal each other. All right. So think back to the last assignment when we'd say m equals a to the log base a of m. Remember, if the bases match, we just took whatever was here and put that up here. So I'm replacing m with this times, do the same thing with n, a to the log base b of m. Now, if I'm multiplying my bases, I add the exponents. Now this log base a cancels out this a because the bases match and it equals the exponent. So that's why I know this log equals these two separate ones. And we could do that for all three of them. You can kind of look through, but the proofs that you're going to see aren't going to be super complicated. It's just using rules and working through them, and we'll get better at that. Okay, so we call this condensing. We're taking two separate logs and condensing it into one. Since I am adding the logs, I multiply the numbers. That's it, done. Here, the logs are both the same. I'm taking two separate logs. Since I'm subtracting, I divide the numbers, and it's just 3. Now, this is where it says, or as an integer. Here, my bases match. This can be simplified. What's this exponent? This exponent is 1. So the bases cancel each other out, and it can be simplified down to 1. I couldn't do that here because if the base isn't written, I know this is base 10. If these don't match or you can't match them, this is all you can do. So that's why it said a single log. This one could be broken down more into an integer though. Okay, for this one, you got to be careful. We can't condense until they're both logs. The very first thing I'm going to do, I need to replace this number with log base 2. In order to condense two things into a single log, first they both need to be logs. All right, so you got to think about this a little bit. First, I needed to make sure these two were the same. Then this is telling me I'm going to, whatever I put here has to equal 1. That means when the bases match, I match these two bases. This number is the exponent. Just like back here. This was 1 when these were both 3s. This is 1. In this case, if they're both 2s, because the first thing I had to match was this base to this base. And then I had to match these two bases and put this in the exponent position. All right, as soon as we do that, the log base 2s are the same. So I bring down log base 2 and I'm subtracting the logs. 2 to the first is just 2. So I'm going to take this 5 and divide this 2. And I can't do anything with this to match the base, so it's just a single log. Okay, so this says rewrite as a single logarithm or as a rational number. The first thing, this is the third property we haven't had a chance to use yet. If there's anything in the front of the log, the very first thing you need to do is bring it back to being an exponent. This needs to move back to being an exponent. Log of 7 squared minus log of 2 to the third. I'm going to rewrite these numbers as just regular old numbers. 7 squared is 49 minus 2 to the third is 8. So we're just taking everything in stages. Move the front number back to being an exponent. Find this value. Now I can condense into a single log. Since I'm subtracting my logs, I divide the numbers. That's all I can do with that one. All right, here we've got to be a little more creative. First, I'm going to move this back to being an exponent. Log of 3 squared is 9, plus I can't combine anything until I change this. So I'm changing this into log, and it's log base 10. Remember, if there's not a number in the base, that's base 10. So that means this needs to be 10 to this exponent. So first I match these two bases, then I match these two bases and put this number in as the exponent. So this is log 9. This is log 1000. Now I'm adding the logs. So I will multiply the numbers. And that's it with that one. All right, I'm going to clear this off so I have room for letter C. So if you need to pause it, if you want to look at it a little more. All right, so letter C. First thing we're going to do is replace both of these. These are both 2 to a power. 8 is 2 to the third. 4 is 2 squared. Now I can move my exponents to the front and I get log. So I'm going to move this exponent to the front. 3 times log 2. I can move this exponent to the front. 2 times log 2. Now notice these are being multiplied. These are being multiplied. I can cancel these as common factors and reduce down to just 3/2. And this is my final answer. So sometimes you have to be kind of sneaky on what you're doing. Okay. All right. So the last couple examples, we're showing that the left side equals the right side. If we're showing something, we can't start with this side. I'm going to start with log of 1/9. And I'm going to use properties and move my way down until I get to this point. All right, my first step is I'm going to replace 9 with 3 squared. Then I'm going to move the 3 squared out of the denominator, which means I need to make my numerator or my exponent negative. I'm then allowed to move my exponent to the front, and voila, my left side equals my right side. This is a proof. When it says show that, we just used properties to show that the left side equals the right side. Okay, now we've got to think about what we were doing before and how we're going to get this. Okay, so first of all, we want to think about what is log of 500. All right, so 500. So my first thought is that's 5 times 100. All right, and we're going to kind of play with this a little bit. And let's see if this is what we want. That would give me log of 5 plus log of 100. Okay, right away, I can see this isn't what I want because this is adding and this side's subtracting. So we got to rethink. This isn't what I want. And this would give me log 5 and this would give me 2. So nothing is on the right track. So let's kind of start over. And let's think, okay, so we're subtracting. So what does that mean I need to do on this side? That means I'm going to have to divide, right? To get to subtraction, we're going to need to divide. All right, so now let's keep thinking. Oops, too many zeros. We need to replace 500 with something divided by something else. Now, if I'm dividing by log of 2, wouldn't that mean I'm going to have 2 on the bottom? So when I divide, I subtract. What number divided by 2 is 500? 1,000 divided by 2 is 500. So let's play with that. See how you kind of just want to mess with it? And then if you see you're on the wrong track, you just kind of start all over. And you could see when we first started, where we went wrong was I needed a minus and I was going towards pluses. That's why we needed to reevaluate. All right, so let's see if this is going to be what we need. So now I'm dividing, so I can separate my logs. Log 1,000 minus log of 2. All right, so we have log of 2. We have the minus. What's log of 1,000? Well, this is log base 10. And 1,000 is 10 to the third. So my bases cancel. And voila. All right. And that's it.